Okay, YouTube, this is my first video in my module on logarithms, in which we're essentially just going to define what logarithms are and talk about how we write them in one way or another. So let's go ahead and start and talk about what a logarithm is. First things first, we'll go ahead and take a look at this particular situation. We would say that 2 to the second power. We would certainly call this 4, and we would say 2 to the third power. We could call this 8. Of course, 2 times 2 times 2 is 8. But the real question that we're going to start to tackle here in this video is, what if I had 6, which is intermediate with our 4 and our 8 here? It's kind of halfway between these two. Would we have an exponent that could give us this 6 if we took 2 to the power of this? And certainly if we could say logically here, I suppose if 6 is halfway between 4 and 8, then maybe this exponent here, is it perhaps between 2 and 3? And so we would say it's 2.5. Well, what I want to show you essentially is that on our calculator here, we'll just go ahead and turn this guy on. We're going to take 2 to the power of 2.5. And the first thing I want you to notice is that you actually get an answer. And the second thing I want you to notice is that you don't get 6. As a matter of fact, you're getting close to 6, but not exactly 6. And so one way to confront this and say, well, what could I take 2 to the power of to get 6 is we could kind of play around with this. We say, well, 2.6, that's over 6 now. So maybe we do 2 to the power of 2.55, and we're getting somewhat closer, maybe 2 to the power of 2.57. You could see how we could continue to get closer and closer and closer to this out further and further decimal values. And so when we talk about a logarithm, what a logarithm is, we say that we define this exponent right here using a logarithm. And we say mathematicians in general use this x value using a logarithm. So define this x value using a logarithm and write it as this. We say x equals log base 2 of 6. And so what we want to say is that these two statements right here are essentially equivalent when it comes down to things. So we're going to talk about an exponential expression, okay? An exponential expression. And this exponential expression, of course, is our 2 to the power of x equals 6. We can see that this is exponential because our variable is our our exponent is our independent variable here. But when we talk about a logarithmic expression, the first thing we want to recognize is that a logarithm here essentially is another way of writing this x value right here. And so if that's the case, and x is really an exponent, but x is also equal to this logarithm, then the very first thing we want to recognize is this. A log or a logarithm is an exponent. And truly, the only thing that's different about a log is how we write it. So we would say a log is another way to write an exponent. A log is a different way to write the exponent, okay? And so essentially when we go forward here, we're going to see that this statement here, x equals log base 2 of 6. In this video, what we're going to work on is kind of comparing these two statements and talking about how they relate to one another. But we'd say that the definition of a logarithm is basically generalized in this way here. And so looking at our specific case, we say 2 to the x equals 6, only if x equals log base 2 of 6. Then what I want you to see is on both of these here, we have an expression that contains a base. And so as we would read this right here, we would say that this is log base 2 of 6 is how this would be read. But you can see that the base on our log here is the same thing as the base on our exponential expression. And so with respect to what this has, we're saying that 2 to some power equals 6. Well, over here with our logarithm, we're saying that this is the same thing as log base 2 of 6 equals x. So really, we're saying that 2 to some magical power here really turns into this bigger value right here. And we'd say, well, what is that power that we took it to? We took it to this power right here. So in general, what we're going to look at is how we rewrite from exponential form into logarithmic and get from logarithmic back to exponential. And the definition of a logarithm with a base b here is as follows. And we'll talk about how we could write back and forth. But we'd say, let b and y be positive real numbers where our base is not equal to 1. So we're going to make this little note here. Our base doesn't equal 1. It says the logarithm of y with base b is denoted log base b of y. And so we would read this as log base b of y is how we would read that logarithm. And it's defined as follows. And so we would say that the log base b of y is equal to x. That's what it equals. But if and only if b to the x power equals y. So one thing that we want to make sure that we do here before we go any further is to kind of compare these two different types of expressions. In terms of which one's logarithmic, it'll always be clear which one's the logarithmic, I guess, form of writing this because it's going to say log. But the exponential expression here is exponential because our variable is in the exponent here. So with both of these expressions here, we say that both of them at the very least have a base, and you'll notice that the base here is b. So one thing we want to write here is that they have the same bases. If you write it in exponential notation or in logarithmic notation, you're going to have the same bases. Now with respect to this statement on the left here, and I forgot to put in our x here, we'd say that it compares to the statement on the right in this way, and here's how we'll read a logarithm. Really, a logarithm is asking the question, what could we take this little number or subscript to the power of to turn it into this power of y? And so as we rewrite it into exponential notation, we can see that we get b to the x is equal to y. But in other words, what we're saying here is that b to the x power is equal to y. And so what I've got here is this arrow situation where we would say from the subscript we go across the equal sign. We would say b, or the base to the power across from the equal sign, turns into this bigger written number here. And so you could see that writing from logarithmic formation, log form, okay, log notation into exponential notation, we would just say you grab your base here, take it to the power of this thing on the other side of the equation, and it turns into y here. This would be the same thing as this right here. Now to rewrite this in logarithmic notation, I suppose we would say, well, our base would have to be the same. And we're saying that we took b to the power of something and it turned into what? Well, it turned into y. So b to the power of something turned into y, and what was that power? Well, we would say that power must have been our x here. But you can see that rewriting it again, we get b to the x equals y. So what we're going to do, and essentially all I want to do in this video, is go ahead and start with the fact that a logarithm is just another way of writing an exponent. And what we want to do is take these expressions in logarithmic form and rewrite them exponentially. And we'll write these exponential form expressions here, or equations, in terms of logarithmic form. So let's go ahead and take a look at a through d here. Essentially, when we look at this logarithm, we say that log base 2 of 16 is equal to 4 is how we would read it. But essentially what we're saying is, hey, we took 2 to the power of something and we got 16. So really, what's the answer there? I mean, what could we take 2 to the power of to get 16? Well, it's not that we're trying to find the answer here. They've already actually provided us with this. So what we're trying to do is just rewrite this exponentially. So exponential expressions. Remember that an exponential expression would be something to the power of something equals something. And the way we're going to rewrite logs in this way is, starting at the subscript, we're going to go ahead and go around in this circular fashion here. We say 2 is our base. Both of these expressions have a base of 2. And we're saying 2 to the power of what? Well, 2 to the power of 4 turned into 16. So this expression right here would be the exponential form of the same logarithmic form that you see here. So rewriting the rest of these, we could see that it's pretty simple. After you get used to one of those, you can see that all of these follow this format. We would say that 4 to what power turns into 1, and of course 4 to the 0 power would have to turn into 1 there. So here's our exponential notation. If we look at this next expression here, our base is 12. So we would say 12 to the power of what? Well, 12 to the power of 1, and that turns into what? Well, that turns into 12 here. And then last but not least, we'd say, well, what could I take 1/4, which is our base on both of these, what could I take 1/4 to the power of to get this? And we would say, well, 1/4 to the power of -1 here. That would be the same thing as -1, well, I guess 1/4 to the +1, but it's reciprocal, and so we would get this 4 that you see here. So using this kind of circular notation here, you could kind of easily scrap together your exponential form. Now, going from exponential back into logarithmic, this is something new for a lot of people. So the way we're going to do this is we're going to start by acknowledging that when we write something in logarithmic form, we have log base something of something is something. And so when we write this out, one thing that we want to acknowledge is that we have the same bases on both of these. And because we have this circular relationship, we're saying that 5 to some power turned into this. Really what I see up here is that 5 to the second power turns into 25. So in other words, what can I take 5 to the power of to get 25? Well, it'd have to be 2. So looking at the rest of these expressions, again, we would say here we get log base something of something turns into something here. And again, using circular kind of notation here, we would say, well, what's the base? Well, the base on both of these would have to be 10. And 10 to the power of -1 would turn this into 0.1, or in other words, we would say that that's the same thing, by the way, as 1/10 there. So for the rest of these, let's go ahead and take a look how we'd write them logarithmically. Maybe without this circular deal here, we would say, well, what's our base? Well, our base here would be log base 8. And we're saying that 8 to the power of something turned into 4. So we would say that since it turned into 4, our 4 would go here, and we'd say, well, what could I take 8 to the power of to get our 4 here? It would be to the 2/3 power there. And then last but not least, we'd say, well, looking at this one here, what's our base? Our log base is 6. And we said 6 taken to the power of -3 turned into 1 over 216. So 6 to the power of what equals 1 over 216? You'd have to take 6 to the power of -3 to get 1 over 216. So this is how we would write back and forth between logarithmic and exponential forms. That's going to play a key role in doing all the tasks that we need to do going forward. Cheers.